So let's talk about adding and subtracting polynomials. We've talked about how to name them. Now what can we do with them? Well, we can add and subtract them just like we did regular integers, positive and negative numbers. So the first thing that we need to know is in order to follow our order of operations, we would have to get rid of any parentheses that we have. So we are always going to distribute to drop the parentheses. So distribute to drop down your parentheses, and then after you do that, you're going to combine like terms. And just remember, like terms are any terms that have the exact same variable factors. We worked with them last year, so hopefully you still remember how to identify those. But let's take a look at some examples so you can just refresh your memory on identifying like terms. All right, so number 16. The first thing I'm going to do is I'm going to distribute something that's out front. I'm going to distribute it in because that's the only way I can get rid of parentheses. Now, in my first one, I'm distributing a positive 1, which when you multiply by a positive 1, it doesn't change anything. So my first set is going to be 4n minus 3n to the fourth minus 5n cubed, or squared. Nothing changes. The second one, though, I'm going to distribute this entire thing, which is a negative 1. And remember, anytime you multiply by a negative 1, it changes the sign. So when I distribute this to all three parts, it's going to change the sign of every single part. So instead of a 3n, I'm going to have a negative 3n. Instead of positive 7n squared, I'm going to have negative 7n squared. And instead of positive 8n to the 4, I'm going to have negative 8n to the 4. So once I've distributed that, my parentheses are gone, then I can start looking for like terms. And you are going to need highlighters galore for this lesson. So if you don't have them already, pause them and get them. Here's what I like to do. Start over to the left and then just work your way across until everything is accounted for. So this first term, I'm going to highlight the whole term, is an n term with the exponent of 1. I can only combine it with other n terms. So I'm going to go down the line, and anywhere I see an n term like this, I'm going to highlight it orange because they match. They go together. That's all for n by itself, n to the 1. My next term is n to the fourth. I have negative 3n to the fourth, so I'm going to go down the line looking for any n to the fourths. Oh, there's one. So I'm going to highlight this entire term so that it matches. And then last but not least, I have n squared. And looking for any more, here's one, so there's that. And you can highlight them, you can circle them, whatever you need to do to identify that these go together, okay? So that way you don't get confused and start combining things all over the place. So once we have them combined, now what I'm going to do is I'm going to start with the highest exponent first, the biggest exponent first, because remember, standard form, you start with the biggest and you work your way down. So let's see, the highest one, I've got 1, 4, 2, and that's it. So 4 is my highest. So I've got a negative 3n to the 4 and a negative 8n to the 4. The variable is going to stay the same. We're still just combining n to the fourth power. How many of them do we have? We have negative 3 and negative 8. When I combine those two negative numbers, I will get negative 11. So I have negative 11 n to the fourth. Those are all of my n to the fourth terms, so I'm going to cross them out. They're done with. Now next I have squared. So here's a squared term, and here's a squared term. It's still going to be n squared. But how many n squareds do I have? I have negative 5 and negative 7. When I combine that, I get negative 12. So I have negative 12 n squared. Okay? So those are done. I cross them out. Now my last term, or my last type of term, is my n terms. Well, how many n terms do I have? It's still going to be n. How many? 4 and negative 3. When I combine those together, will give me a positive 1. So now my final answer here for combining all of this is negative 11 n to the fourth minus 12 n squared plus 1n. And of course, 1 doesn't have to be there. So if you are looking for an answer on a test sheet or something like that and you don't see the 1, just remember, it's okay if it's not there. It's okay if it is there. it means the same thing. So this then would be our final sum of these two polynomials. We took these two polynomials, we combined them together. In this case, it was subtraction. So here's the difference of those two. Let's take a look at another one. Let's take a look at number 19. Again, I have a positive 1 here. I have a negative 1 here. This positive 1, when I distribute it to all of my terms, isn't going to change anything. So it'll still be negative 7x plus 2x to the 5th plus 5x to the 4th. But when I distribute my negative 1, now when I distribute it, it's going to change all my signs because that's what multiplying by a negative 1 does. So instead of having a 2x, I'll have negative 2x. Instead of having plus 5x to the 5th, I'll have minus 5x to the 5th. Instead of plus 8x to the 4th, I'll have minus 8x to the 4th. And now it's just a matter of highlighting my terms, looking for terms that match. So my first one is just an x. Any other x's? There's one. No others. Next I have x to the 5th. Any other x to the 5ths? There's one. And then I have x to the 4th. Any other ones like that? Yep. There we go. So now that I have all of my terms highlighted and I can see which terms go together, I'm going to go ahead and combine them. So starting with my biggest one is x to the 5th. So I have a positive 2 and a negative 5. It's still going to be x to the 5th. When I combine these two, negative 2 and negative 5 is going to give me negative 7. Those are done, so I cross them out. Next I have x to the 4th. All right, how many x to the 4th terms do I have? I've got 5 and negative 8. When I combine those, I'll get negative 3. So that's the coefficient on the x to the 4th term. Those are done, so I cross them out. Then I have my x terms. Negative 7 and negative 2 gives me negative 9. Those are done, so I cross them out. And that's all there is to it. Negative 7x to the 5th minus 3x to the 4th minus 9x. You're done. Let's take a look down at some of these bigger ones, like number 22. This one's ginormous. All right. First, distribute to drop parentheses. You can't combine anything until it's out of parentheses anyway. So I have a positive 1, positive 1, positive 1. Guess what? If I distribute positive 1, nothing's going to change. So in this case, when I distribute, everything stays exactly the same as it already is. Positive 6, positive 7x, negative 3x to the 5th, positive 4, negative x, or 6x to the 4th, minus 7x. There we go. Everything's the same. Now, I'm going to start on the left, and I'm going to start looking for terms that I can pair up together. So this one starts out with a 5th. Let's see, any other 5ths? Yep, there's negative 3x to the 5th. Now I have a squared term, x squared. Any other x squared? Nope, so that stays by itself, no problem. How about x to the 4th? Do I have any other x to the 4th? There's one. Highlight it to match. Pulling out another color, and I'm going to go green here just to make it easier for you guys to see. So I have x, and I skipped one. I'm so sorry. You know what? My head just went straight to the variable. Just goes to show you it doesn't really matter, but going left to right will help you make sure that you hit everything and that nothing gets left out. And my last highlighter is actually really hard to read, so instead of highlighting it, I'm just going to circle it with my red pen. Okay, so I know that those two go together. So now we're going to go back and we're going to write this polynomial, whatever it is, when we combine everything together, we're going to write that in standard form. So we're going to start with the biggest exponent, which is 5. So for my x to the 5th, I have 5 and negative 3. When I combine those, I will get a positive 2. They're done. Next, I have a 4th. So x to the 4th, positive 2, negative 6. When I combine a positive 2 and a negative 6, I get negative 4. So that goes in front there. Those are done. Next, I have a squared term, x squared. Well, there's nothing to combine it with, so it's just going to stay a positive 4x squared. Done. Next, I have my x terms, a positive 7 and a negative 7. Those are going to cancel each other out. Positive and negative, they're exactly the same. They're going to go bye-bye. And then I have a positive 6 and a positive 4 gives me positive 10. And and I've combined all of my like terms. Now, it's a really good idea, once you've combined all your like terms, just double check and make sure that you are in fact in standard form. So we've got 5, 4, 2, 0. That is in descending order, so we are good to go there. Last but not least, let's take a look at 24. This one is ginormous, but I know you can get it. We have a positive 1 out front here, a negative 1 here, and a positive 1 here. So I'm going to go ahead and distribute all of these 1s. When I distribute a positive 1, nothing changes. So this one just stays the same. I'm just going to copy it right underneath. No sweat. When I distribute a negative 1, it's going to change all of my signs. So instead of negative 8x to the 4th, I'll have positive 8x to the 4th. Instead of negative 2x to the 5th, I'll have positive 2x to the 5th. Instead of negative 7, positive 7, and a positive here as well. Now here I have a positive 1 to distribute. That doesn't change anything, so I'm just going to copy my expression just like it was. Good old polynomial stays the same. And now I have this big long string of terms, which is crazy humongous. But I'm going to combine like terms so that it won't be so big, okay? And again, I'm just going to start at the left and work my way across. Slow and steady wins the race. So now we combine. So starting with our big ones, and actually, you know what I'm going to do, since this one is so humongous and I don't want to miss anything, I'm going to go ahead and just combine left to right. And this is a strategy that you can use. You don't have to. If you want to find the biggest exponent and start with that one, do it. But this is a lot, and I'm afraid I might miss something. So I'm just going to start with my x cubed. Where's my other pink? Pink, pink. So I have 8 and negative 5 combined to make positive 3. Done and done. Next I have the 4th, x to the 4th. Where's my other yellows? Any other yellows? There we go. All right, so I have 4 plus 8 is 12, minus 4 is 8. So positive 8, x to the 4th, because the variable stays the same. Now let's see, I have x squared is my oranges, orange, orange. Okay, x squared. Now I've got 4 plus 4 is 8, plus 8 is 16. Woo! Lots of x squareds. Gone, gone, gone. Next I have x to the 5th, and those are my green ones. There's one, that's all I have. Okay, so negative 7 and positive 2. Oh, nope, that's a positive 7. Whew! Be careful if you circle it. Don't change your sign. Positive 7, positive 2 gives me positive 9. And then this is crossed out, crossed out. Okay, so now it's just my constants. So I have positive 7 and positive 7 gives me positive 14. Now I'm going to go back and rearrange it. Now that I'm not looking at this humongous string of terms, it's just a few terms, and I know that everything is combined, so none of the exponents are going to be repeated. Now it's easier to look for what's bigger. So just looking at my exponents here. Just looking at my exponents, which one's biggest? 5. Positive 9x to the 5th. Done. Next comes 4. Positive 8x to the 4th. Done. Next comes cubed. Positive 3x cubed. Done. Next comes squared. Positive 16x squared. Done. And I don't have an x term by itself, but I do have a constant to tack on at the very end. And now my polynomial is in standard form, and I can be done. So sometimes it's just easier to wait until the very end to put everything in order. Whatever works for you will totally work for me. Just double check at the end to make sure you're in standard form. Finish up the rest of these problems and bring them into class tomorrow ready to discuss if you have any questions.